Hello, in this video I'm going to explain adding and subtracting fractions with unlike denominators. By unlike denominators, what we mean is that the numbers in the denominator are different. They are not the same. Now at the end of the last video we kind of touched on how do we handle that. So before I dive into this first question here, I'm going to do a little review on that process. So when we're adding and subtracting fractions with unlike denominators, what we have to do is a four-step process. So the first step we have to do is we have to find the lowest common denominator. So recall from the last video, the lowest common denominator is the least common multiple of the denominators. So the LCD and LCM are the same thing. So the LCD is the smallest number possible that both denominators divide into. We want to keep this low, and that's why it's called lowest, so that way the fractions don't become too big and the numbers become out of control and difficult to complete. We want the lowest possible number for the denominator that's common to both, so that way the numbers will stay small and the arithmetic will become easy. So after we find the LCD, step 2 is to multiply by some number over some other number. We need to multiply. And I'll explain this obviously as we get into these questions, but we need to multiply the denominator by some number to give us the LCD, okay? And whatever that number is in the denominator, we got to multiply also the numerator by that number to keep the ratio of the fraction the same. So that's what n over n means. N is that number we got to multiply by the denominator to get the LCD, and whatever this is the same. It's going to be the same. N over n, whatever number it is, over itself is 1. So we're not really changing the value of the fraction, we're changing its size. Okay, so after we do that, then we add or subtract the numerators only. We do not add or subtract denominators, and I explained that in a previous video. Okay, so the denominators stay the same, but the numerators we're going to add or subtract depending on what the problem involves. And then finally, step number 4 is to reduce, if possible. So you want to make the fraction smaller, as low as you can do it, all the way down as small of a number as you can get, down to lowest terms. Okay, so you want to reduce the fraction all the way down as far as you can. Now, some fractions will not reduce, so don't try to reduce something that cannot reduce. But if it can, they expect you to reduce. See that? Simplified fraction. Reduce, that's what that means. All right, so with those 4 steps, we're going to do these problems here. All right, so we have question number 1. 3/4 plus 1/16. Now, remember from the last video that we can use a couple different techniques to find the LCD. Step number 1, LCD. We can use the factor tree technique, right, between this and this, or we can use the one list of multiples. What do you think is the easiest to do here? Factor tree or one list of multiples? One list of multiples, you said. Correct. Because remember, for the one list of multiples, we ask the question, can 4 the smaller of the two denominators, can the smaller denominator divide evenly into the bigger denominator? And the answer is definitely, yes, it can. So therefore, the LCD is the bigger denominator. Why is it the bigger? Because 4 divides into 16, and 16 divides into 16. We could not say 4 because 16 would not be able to divide into 4. Okay? So remember, this is the lowest number possible that both denominators can divide into. Now that we have that, we're going to multiply by some number, right? N over n as a reminder. That's a reminder. So how do we handle this? Well, rewrite the question. My recommendation is to rewrite the question. Don't get lazy here. Don't write anything here. This is the original question. Leave it alone. That way you can see the steps as you complete them. So don't touch the original fraction. Just rewrite it. 3/4 plus. Now leave a little space here. I'll show you why. 1/16. Also leave a little space here, and I did leave a little space there. We need to leave a little space because we got to multiply by some number, right? We got to ask ourselves, what number times 4 will give us our LCD of 16? And that number is 4. 4 times 4 is 16. We need to make both denominators become 16. So if we multiply this by 4, we got to do the same to the top. We got to multiply the numerator by 4. And that's what I mean by n over n. See that? Whatever number this is, it's the same thing, which is really 1, right? We're not changing the ratio. We're making it bigger. We're increasing the size of the fraction so that way this matches the denominator, the LCD. That way the denominator matches the LCD. That's what we're looking to do. All right, so leave this alone for now. Now let's move over to the next fraction. Put your multiplication dot here and ask yourself, what number times 16 is 16? Well, that number is 1. So if we multiply this by 1, we got to multiply this by 1. Now, I only did this to show you that what we do to one, we do to both. However, though, if one of the two fractions already has the LCD, you do not have to do this little step here, because we know that 1 times the denominator is the LCD. And it's not going to change this fraction, right? It's going to be the same. I only did this here just to show you that, yeah, we could do it if we want to. But if it does happen to be the same as the LCD, if this denominator is the same as the LCD, don't multiply by 1. It's not necessary. So I won't do this again for the rest of the video. All right, so let's multiply this out. We have 4 times 3 is 12. We know the denominator is 16 without even thinking about it. 1 times 1 is 1. 1 times 16 is 16. All right, so we manipulated this fraction. We made it bigger, at least this fraction, right? We made it bigger so that way the denominator matches this denominator based on the LCD. And recall that 12/16 does reduce to 3/4, right? So these are the same. It's just that this is bigger. All right, so we're halfway done. Step number 3, which is always the easiest step. In this case, we're adding. Add. All right, let's add. 12 plus 1 is 13 over 16. Remember that we cannot add denominators, only the numerators. Step 4, reduce. Can we here? No, we cannot reduce. We cannot reduce. This is our answer. We're done. Right there. So this question wasn't too bad because we only had to manipulate one fraction, and the other thing is the numbers were pretty reasonable. Some numbers in Math 50 and maybe here we'll see are pretty big, so they're more difficult. However, though, the 4 steps will be the same, right? It's going to be the same 4 steps regardless of how big the numbers are or if we're adding and subtracting. So let's try 13 over 16. Okay. So while I'm writing this down, what do you think? The one list of multiples technique for the LCD or the factor tree? And you said one list of multiples, correct. 7, the smaller number of the two, divides into the bigger number evenly with no remainder. Therefore, the bigger number is the LCD. 7 divides into 14, 14 divides into 14. Now that we got our LCD, we got to multiply by some number over some number. Rewrite this, leave some space. Now, here we can see this has the LCD. I'm not going to do the 1 over 1 again. I'm just going to write this right next to it here. No extra space needed. Because I can see that this is the LCD, right? So, what number, and you always multiply with the denominator first, not the numerator. We want to know how can we change this number in the denominator to make it the LCD, 14. What number times 7 is 14, and that's 2. And then you do your numerator, and whatever this is the same thing. All right, so let's multiply this out. So we have 2 times 3, 6 over 14, plus 3 over 14. Let's go to step 3. Add numerators, 9 over 14. Keep denominators. Step 4. Can we reduce? No. Done. All right, so 1/4 plus 1/5. LCD. Here we could use either one list of multiples or the factor tree. Let's try the one list of multiples just to practice that a little bit. The first 2 questions were pretty easy, right? Because the first multiple, we got a match on the first multiple to find the LCD. Here, as you can see, we're not going to get the first match. So let's try the one list of multiples. So, does the smaller number divide into the big number evenly? No. So we take the next multiple of the bigger number, right? 1 times 5 is 5, and 4 does not divide into 5. 2 times 5 is 10. Does 4 divide into 10? No. 3 times 5 is 15. Does 4, the smaller number, divide into 15? No. 4 times 5 is 20. Does a small number divide into 20? Yes. One list of multiples. Also, you might note that this is a prime number, and this is the same as 2 times 2, right? Down to the prime numbers, 2 times 2. There's no common primes between them. So you could just multiply this out. In fact, that's what we did right here. 4 times 5 is 20. But don't automatically multiply the denominators out. I've seen students do that. Oh, that's how I learned. That's how somebody showed me one time. He doesn't always get you the LCD. He might get you something humongous, Then you got to add big numbers and then reduce big numbers. Not a good idea, bad strategy. However, if you can see that there's no common factors, okay, then you can multiply it out. So we got 20. LCD is 20. Step 2, n over n. Multiply, right? Now leave a space for both of these numbers because neither one is the LCD. So leave a little space here to the left of both fractions so we can multiply by something. What number times 4 is 20, and that number is 5, right there, right? If that's 5, that's 5. What number times 5 is 20, and that number is 4? 4. And I mentioned this in the previous video, but it's worth mentioning again. The numbers up and down here, the numbers up and down, always are the same. That way we don't mess up the ratio of the fraction. If this is 5, that's 5. Same thing here. If this is 4, this is 4. So up and down, the numbers will always be the same. However, when you look at them side to side, they're different. Of course they're different. They're different because the denominators are different. That's why, right? So don't be, I've seen students be confused. Why is this 4? Why is this 5? Well, that's because the numbers are different. And it's going to take different numbers to multiply these to get 20. That's why. All right. 5 times 1 is 5 over 20. So remember, when you're multiplying denominator, don't even think about it. There's our answer without even thinking about it. All right, so we got this. So step 3 here, we're going to add numerators. 9 over 20 over 20. And step 4. Should we reduce this? No, you said. Correct. It does not reduce. So there it is. We're done. 9 over 20. Okay, now look at this one here as I'm writing it down. What do you think? The one list of multiples or the factor tree? One over 27 plus 5/6. Well, first of all, if we did the one list of multiples, we would look to see, can 6 go into 27? It does not. And then we have to multiply 27 with the next multiple. And actually, it would work. It would work, right? Actually, let's do both. Let's do both. Let's do both. So can 6, the smaller number, divide into 27? No. Take the next multiple of 27. And you can do this up here on the side if you need to. So 2 times 27 is 54. Does 6 divide into 54? Actually, it does. So we got it here. But I think it's a good idea to practice the factor tree. So let's do both. And we'll just make sure it's the same number. So we have 27 here. And then here we got 6. Put a little divider here so that way we don't cross over with our factors as we're going down the branches. So 27 is the same as 3 prime, circle your prime numbers, times 9. And 9 is the same as 3 times 3. 6 is the same as 2 times 3. LCD. All right, so here we have on this side of the divider, we have 3 3s. So I'm looking to compare the circled numbers, the prime numbers, for a specific number, right? And we only got 3's here, which are the prime numbers that are circled. And I went over this in the last video, but I'll obviously walk through you some more again. So we have 3 3's on this side, and we have 1 3 on this side. There are more 3's on this side, so the side with the most, right? Remember that? LCM, LCD, most, the bigger. Okay, so 3 3's come down. The winner comes down, the loser stays back. You can think of it that way. All right. Now, we'll move on to the next number that's circled, which is 2. 1 2 here, no 2's here. There are more 2's here, so the 2 comes down. We already looked at the 3, and it's staying back because they won out. This stays back. So now we can multiply this out. Well, we got 3 times 3 is 9. 9. 3 times 2 is 6. And 9 times 6 is 54. So you wouldn't want to do both techniques. But I just want to show you that they both work. And if you didn't know, if you couldn't see that 2 times 27 is 54, that's fine. Just simply go to the factor tree, because this is a pretty big number here, no doubt. All right, so anyway, we got our LCD, 54. Step 2, n over n. We've got to multiply by some number. So we have 1/27th, leave a little space on the left, plus 5/6, leave some space on the left. What number times 27 is 54? And you can kind of see here, this is 27, right? 3 times 3 times 3 is 27. 27 times 2 is 54. If that's 2, that's 2. What number times 6 is 54? Well, here's our 6. 3 times 2 is 6, which means 9. 3 times 3 is 9. 9 times 6 is 54. If that's 9, that's 9. All right, multiply across. We got 2 over 54. And we got 45 over 54. Step 3, add numerators. We got 47 over 54. Not an easy number to try to see if you can reduce. However, it does help to know your prime numbers. Also, this is an odd number. So we know no even number divides into it. Does 3 divide into it? Let's use the divisibility rule. 4 plus 7 is 11. 3 does not go into 11. It's the same rule for 9. So 9 does not go into it. 5 does not go into it. Nah, this seems to be a prime number, which means it cannot break down. This is a composite that cannot break down, but that's not going to help us because we need a factor, a similar fraction top and bottom, so we can slash them out, right? So we can cancel them. But we cannot break this down, and that's going to be our answer. Let's try it. All right. So we got 1/5 plus 1/6. Factor tree or the one list of multiples. Let's try the factor tree. So we got 5. We got 6. 5 is prime. Bring it down, circle it. 2 times 3 is 6. LCD. 1 5 here, no 5's here. There are more 5's here. That comes down. 1 2 here, no 2's here. There are more 2's here. That comes down. 1 3 here, no 3's here. More 3's here. That comes down. 5 times 2 is 10, times 3 is 30. And also you can tell from the fact that this is a prime number, and this has the prime numbers of 2 and 3. If there's nothing common between them, multiply them out. 5 times 6 is 30. LCD is 30. Next step. And if you want, for your own sake, you can put step 1, step 2, step 3, if you want. It's really up to you. And I'm being, at first I was writing the steps down, but now I think you're getting the flow of it. So after we find the LCD, we know we got to multiply by something. So we write the original problem. 1/5, leave some space between each fraction, 1/6. What number times 5 is 30? 6. If that's 6, this is 6. What number times 6 is 30? 5. That's 5. This is 5. Okay, multiply across. Let's do it down here. So we got 6 over 30 plus 5 over 30. Add numerators. We cannot reduce. 11 is a prime number, and 11 does not go into 30. So here it is, right here. Now, some of the fractions in Math 50 are going to be bigger and tougher. And I'm surprised I haven't seen that many big numbers so far, because we have seen big numbers in the LCD, LCM, GCF, right? Remember that? So anyhow, it's still the same 4 steps. So if you're all right with the 4 steps here, even if the numbers are bigger, you'll be fine. So now we're moving to subtraction. It's the exact same thing. There's no difference at all. Except step 3, we're subtracting numerators instead of adding. Other than that, it's the same thing. 4/5 minus 1/6. Now, we kind of just did this, right? We did this. We know what the LCD is. Yeah, LCD is 30. LCD, we just did that, right? All right, so let's rewrite this. 4/5 minus 1/6. And we know that 6 times 5 is 30, which means we got to multiply by 6. We know that 5 times 6 is 30. We got to multiply by 5. Then we multiply numerators and denominators, so we get 24 over 30 minus 5 over 30. So the only difference is we're subtracting now rather than adding. Other than that, it's the exact same process. So what do we get? 24 minus 5 is 19 over 30. 19 is prime, you said. Correct. Which means this does not reduce, and 19 does not go into 30. We're done. So what do you think? For the LCD, are we using the factor tree or the one list of multiples? Which would be quicker? And you said one list of multiples. Correct. There's no right or wrong here, but the one list of multiples is quicker. Can 10 divide into 15? No. Take the bigger number and multiply it by 2, the next multiple, right? It's one list. That's why they call it the one list of multiples. We're doing multiples of the bigger number. And 2 times 15 is 30. Can 10 divide into 30? Sure can. We got our LCD. Step 2. Put your little multiplication dot here, minus. Put your multiplication dot here. What number times 10 is 30? 3, which means this is 3. What number times 15 is 30? 2, which means this is 2. Multiply this out straight across. You get 21 over 30 minus 2 over 30. Subtract. We get 19 over 30. Well, apparently none of these are reducing, but they will. Like in Math 50, you'll be having to reduce these. And it's not a big deal because I covered reducing before in a previous video. So the lowest number, right? You want the lowest number for top and bottom. So anyway, so let's see if this works. 19 over 30. One list of multiples or the factor tree while I'm writing this down. And you said one list of multiples, correct. Can 4 divide into 12? Yeah, done. Nice. All right. 4 goes into 12, 12 goes into 12. Step 2, 3/4 multiplication dot minus 5/12. And actually, we don't need the space here, right? Because it's the same number. We're not going to multiply by 1. It's not going to change anything. So what number times 4 is 12, the LCD, and that number is 3, which means this number is going to be 3. All right, let's multiply it out. So we got 3 times 3 is 9 over 12 minus 5 over 12. So what does that give us? 9 minus 5 is 4 over 12. And that's the answer, right? No, you said. Correct. Because in step 4, we want to reduce. What's the biggest number you can think of that divides into 4 and 12? You did not say 2 because 2 is not the biggest number. Correct. Instead, you said 4. 4 that you're thinking about divides into 4 one time. 4 that you're thinking about divides into 12 3 times. Cross out the thought bubble and write down what's left. 1 over 3. Nice. All right, so a lot of these apparently are geared for the one list of multiple. And since I already covered the factor tree extensively in a different video, I think you're okay with it. So we'll take the easy way out. If they want to give us the easy way out, we'll take it. And here it is, right? You can see that. LCD is 18, you said. Correct. 9 divides into 18, so 18 is the LCD. 9 divides into 18, 18 divides into 18. So, rewrite. Minus 1 over 18. We'll leave this right here. There's no reason to multiply by 1, right? We got the same denominator here. All right, so 2 times 9 is 18, which means we got to multiply the top by 2. There we go. So we multiply this out. We get 14 over 18 minus 1 over 18. And by the way, I've seen this happen before. Once you get this, the temptation is to reduce. No, don't. It's going to take you back to here. Don't reduce. No. If you reduce, you're going backwards. Leave it like this because we're not done yet. You only reduce at the end with adding and subtracting fractions. Don't reduce while you're performing the steps. Only at the very end do you reduce. So we purposely bumped this fraction up by a factor of 2 so we can get the denominator to become 18 like this guy, the LCD. All right, so let's subtract, see what we get. 14 minus 1 is 13. Keep the denominator. 13 is prime. It does not break down. And we're done. All right, so one more to do. And another one that's on the easy side. Unfortunately, we didn't get the big numbers like you're going to see in Math 50. Still the same technique, though. If you're okay with what I'm doing here, you'll be fine in Math 50. LCD, one list of multiples, right? 3 goes into 12, so 12 is the LCD. Got it? Two thirds minus 5/12. What number times 3 is 12? 4, which makes this a 4. Okay, so multiply numerator and denominator. We get 8 over 12 minus 5 over 12. Let's subtract. 8 minus 5 is 3 over 12. And that's our answer, right? Oh, you said we can reduce? Oh, okay. Good idea. Yeah, let's see. So we have 3 12s. What number? What's the only number besides 1, and 1's not going to help us? What's the only number that divides into 3 and 12? And you said 3. 3 that you're thinking about divides into this 3 once. 3 that you're thinking about divides into 12 4 times. What do we have left? 1 over 4. All right, so there it is. This is how you perform addition and subtraction of fractions with unlike denominators. If you like my content, click on the like button, post your comments below, and subscribe to my channel. Thank you for watching.